In this video, we're starting a new section 12.0, all right? And the 12.0 series is just doing world programs with unions of structures, all right? So we're going to do flip shape in this video, and I have the solution, all right? So you guys will see what it looks like. It's going to grow a red disk, right? And then when I hit space, it's going to grow a red box. So disk, box when I hit space. And they grow sort of in a sort of retain the size when I hit space, right? Like it doesn't reset, all right? And here is the starter file, and there's a lot of things done for us already. So the constants are width, height, 400. The background is this empty scene with that width and height of 400, and we have the half width and half height, all right? All right, so let's move on to problem A. Design a world program that animates a growing red disk and a black box, right? Notice how the data definition step for disk and box are already done. We're going to review those shortly. I'll complete the data design steps for the union shape. So basically just the data examples and the function template for shape. Before we do that, let's just review the structures for disk and box, all right? So disk has a radius. That radius is a number. You can make a disk by make-disk and giving it a number. And the interpretation is that it represents a disk with some radius, right? And disk-radius is an accessor function. You give it a disk and it gets that field out. Here is a template that processes a disk. And likewise, similarly for box. Box has a width and height. Those are numbers. It can use make-box to make a box, giving two numbers. And these are the accessor signatures. And likewise, a template. Okay. Finally, we have our union shape, which is one of either make disk number or make box number. And the interpretation is that this union, this whole thing, is a set of shapes. So try to do the data design steps 3, right? Examples for this union shape, right? Pause the video and try to do that. All right. I'm gonna go for spoilers in 3, 2, and 1. All right, so I'm assuming you took a good swing at it. So now let's go over it together. So the examples for these are that we just have to make a disk. So we'll just do define, we'll say ds, and then do a make disk 30. And then we'll do one more for the box. We'll call it bx, make box, and we'll give it a width of 20 and a height of 30, all right? All right, so that is pretty much it for data examples. Microsoft's done for that. All right, next is a function template that processes a shape, all right? Pause the video and try to do that, right? A function template that processes a union shape. In fact, let me write the signature for you guys. So shape-temp is going to be a template that consumes the shape, and we don't know what it'll spit out yet, right? Okay, so try to do step 4 on your own. I'm going to go for spoilers in 3, 2, and 1. All right, I'm assuming that you took a good swing at it, so now let's go over it together. All right, I'm going to give myself some space here. Okay. So define shape-temp. Let's call the input parameter sh. And likewise, since this is a one of, right, we need a con distinguishing between these two, right? It has to match that number. So 2 here, and we need 2 cases for a cond, like so, distinguishing what they are, right? So is it a disk? We can ask that with disk, given this shape, right? Is this shape a disk? If it is, then we want to take it apart. Likely want to get the radius out. Okay. Likewise, change this parameter to be sh instead of ds. Okay. Let's do the other one. So for the box case, is the given shape a box? If it is, we want to take it apart, take the width and height out, like so. And we're just laying out a good foundation here. All the pieces like so we can use these for all the other functions down the line. All right, so this is where, you know, world programs are pretty big, and in all the previous videos, right, you really only have to instantiate the template like 1 to 2 times. This world programs have you do it like 3 to 4 times, if not more. So this is where it's templates are shining a little more. All right, so just gonna mark myself off for that template step. And we are done with that. Okay, gonna erase this and we can move on to problem B. All right, so let's move on. So problem B, gonna scroll down here. All right, so finish designing the functions in the following order: grow shape, shape arrow image, render. Flip shape and handle key are the hardest to do, so do these last, right? So we're going to have to design 1, 2, 3, 4, 5 functions. And you can see that some of these steps here have already been done for us, right? So here's grow shape, signature, purpose, and the stub. And here's the shape, arrow, image, signature, and purpose. Here's one for render, flip shape, handle key, and the main function for running the Big Bang. All right. So let's just get started with grow shape over here. All right. So grow shape, here's the signature. Grow shape consumes a shape and spits out a shape, right? And it grows, and its purpose is to grow the given shape by increasing its dimensions by 1. And here is a function template for that. All right, so pause the video and try to write some examples for that. Gonna scroll down here for some steps here. All right, so signature and purpose and stub are already done. Try to come up with some examples for grow shape. All right, I'm gonna go over spoilers in 3, 2, and 1. All right, so I'm assuming that you took a good swing at it. So now let's go over it together. All right, so check expect grow shape. All right, we're going to give it the DS, our example, all the way up here. In fact, I'm going to copy and paste these examples down so I don't have to keep scrolling up for them, right? So like so. All right. All right, so given this disk 30, right, what do we want to produce? Well, this has to produce a shape, and the purpose says to grow the shape by increasing its dimensions by 1. And a disk only has a radius, right? So we're just going to increment this by 1. So this 30 is going to be a 31. So we should produce a make disk of 31 when given a make disk of 30, all right? In fact, I'm going to rename DS right here, right? Because it's not obvious what it is. We should come up with more descriptive names for our variables such that we can tell what it is at a glance. So I'm going to call it DS-30, all right? DS-30. That way we know at a glance, hey, this is a disk with a radius of 30, all right? Likewise, I'm going to do the same for this box right here, right? So BX is going to be BX 2030. All right, that's going to be the name of the variable. All right, so that's one example done for the disk, right, which is one of these set of shapes. Let's do the other example when we're given a box, all right? So when grow shape is given a box, that's 2030, right? We want to grow the shape by increasing its dimensions by 1. So this 2030 box should be a 2131 box. So when we're given box 2030, produce a box, make box of 2131. All right, and those are enough examples done. Let's just run our stub against the examples. Been a bunch of failing tests, but it's fine. All right, okie dokie. All right, can I check myself off for those so you can see where we're at in these steps here? All right, signature purpose stubs done. Examples are done. All right, next is the template from data. So is there a template that we can use to leap off of that we scaffolded for shape? Yes, there is. All right, there's shape-temp. Let's just copy that down and use this as a scaffold. All right, gonna comment out the stub here, and then gonna paste this down, and then rename this grow shape, like so. Okie dokie. So that is the template stub done. All right, we got a template. Now comes the hardest part, coding the body for grow shape, all right? So pause the video and try to do the code body for grow shape, all right? I'm gonna go over spoilers in 3, 2, and 1. All right, so I'm assuming we took a good swing at it. So now let's go over it together. All right. So looking at the signature, we have to produce a shape. And looking at our examples, if we're given a disk, right, this is that branch, we have to produce a disk. So this ... should be make disk, all right? Likewise, you have to increase this radius. So we're given a make disk 30 right here. So we just add 1 to that radius. So we're going to wrap this around and add 1 to fulfill our examples. Same with the box case, right? For this box example over here, right? We're given a box with a 20, 30. So this is that 20 and this is that 30. All right, we have to reduce a make box at the end, right? A shape. So this should be make box. And likewise, we're just going to add 1 to both the width and the height. 1 like so, and plus 1 like so. And if we run, all our tests should pass, and so they do. So that is the code body step for that. All right, we can test, review, and refactor later, but this is mostly as simple as we're going to get it. You could make this an else, but it's fine either way. All right, so let's move on to the next one, which is shape arrow image, right? That's the second function that we had to design next. All right, so shape arrow image consumes a shape and produces an image. And here is the purpose, produces the drawing of the given shape. Okay, so signature, purpose, let's stub this out. All right, so we're going to do define shape arrow image, consumes a shape and spits out an image. So we can just spit out an empty image for now, like so. All right, so signature, purpose, stub. Next is the example. So check expect shape arrow image. All right, so if we give it the disk DS30, right? We're converting these structures, so DS30 and BX2030, into images, all right? And the disk corresponds with a circle, right? A red circle with the same radius as the disk structure. Likewise, the box is going to be a rectangle, all right? So shape arrow image, when given a disk shape, a disk structure of 30, the radius of 30, should produce a circle, an image of a circle, right? 30 solid red. All right, and I'm going to run this here off to the side so you can see what it will look like. All right, likewise, it's similar with the other case. So check expect shape arrow image. If we give it a box of 2030, right? Well, we should produce a rectangle, right, of 2030 solid black. Okay. So if we copy this, you guys can see what it'll look like. So we're turning this structure, make box 2030, into an image of it. All right. So we just run our examples against our stub. It fails, right? We get image mismatches, but it's fine. All right. We can go tackle these one by one. All right. Okay. So I'm going to comment out the stub here. All right. The signature purpose stub example is done. All right. Going to check myself off here. So signature purpose stub, examples are done. Next, we're grabbing a template from the body, right? So this thing consumes a shape, right? Shape arrow image consumes a shape. So we can use a template for that we wrote above as a scaffold. So like so. And you're going to copy and paste this down. Rename this to shape arrow image, like so. All right, so that is the template step done. All right, next is coding up the body, which is the hardest part. So hopefully this should be all the mental scaffolding needed to solve the problem. Try to do it on your own. I'm going to go over spoilers in 3, 2, and 1. All right, so I'm assuming that you took a good swing at it. So now let's go over it together. All right, so looking at all these, purpose statements, etc. Right, if we're given a disk, which is this branch over here, we should produce a circle, right? So circle, where we give it the disk radius, right? And then solid red as the other arguments. So solid red, all right? Next test, all right? So check expect shape arrow image, consumes this box. We should produce a rectangle with the width and height of the box and solid black. So rectangle, that is the width of the box, that is the height of the box, and then we have solid black, all right? The template sort of gets most of it done. We just have to fill in the blanks. All right. So we run this, it should pass all our tests, and so they do. All right. Gonna check myself done for the code body of this function. Okie dokie. So now let's move on to the render function. All right. So here's the signature for the render function. It consumes a shape and spits out an image, but it draws the image of a shape on a background, right? That's really important. All right, we're going to draw it on the big empty background. All right, so signature, purpose, stub. Let's do some examples here. Check expect. We're going to do render. If we're given the disk that has a radius 30, what do we expect to produce? Well, we're going to do a placed image where we place a circle that is 30, solid red. All right, red onto the position half width, half height on the background. All right, So if I run this here off to the side, you guys will see what I mean, right? We are placing it at the center of the screen, because half width and half height is the center coordinates of the screen, and background is this big white background in the background. All right, so let's do the other example for the other shape. All right, so I'm gonna do check expect render bx 2030. We're gonna do something very similar, right? Place image, where we this time this given shape, right? We're gonna convert that to an image of a shape. So rectangle with the same dimensions, so 2030, and then it's gonna be solid black. All right, at the coordinates half width with half height onto the background, like so. All right, let's run our stub against our examples. We get mismatches of images, but nothing. Still valid syntax, right? So Racket didn't say there was anything wrong with the examples, just that they mismatch. All right, so I'm going to comment out the stub here, and we're going to grab, since this consumes a shape, and we wrote a template, scaffolding all we need, that we might need for a shape. For things that consume a shape, we can use this as a starter. And we're going to call this render, rename it render like so. Okay, so pause the video. Hopefully this should be all the mental scaffolding needed to code the body of the render function. All right, so we just did the signature purpose stub for that. The examples we just did, we grabbed the template all for that, and then now comes coding up the body for the render function. All right, so pause the video and try to do that on your own. We'll go for spoilers in 3, 2, and 1. All right, so I'm assuming that you took a good swing at it. So now let's go over it together. So looking at the examples here, let's just blindly slap these down, right? So place image of converting this disk into an image of a circle, half width, half height, and background, all right? So we're just gonna place image, turn this into a circle, all right? Circle with the, so that's a 30 right here, all right? I'm going to do solid red, half width, half height onto the background. All right. So that's one case done. All right. So let's do the other case here. All right. So this render bx, if it's a box, right? We want to make it a rectangle. We want to turn the structure into a image of a rectangle 2030. So here's those arguments, and half width, half height, and the background. All right, so we're just slapping these arguments down, wrap this around a call to rectangle, right? This is going to be solid black. All right, gonna space this down. All right, and likely half width, half height onto the background. So half width, half height on the background. So we run this, it should pass all the tests, and so they do, all right? But beyond that though, right, you might be looking at this and saying, wait a second, right? It's this and this. The first argument to place image, right? The circle and rectangle are the only two that's changing. These three say exactly the same. So instead of doing all this where we have two place images, let's just encapsulate this cond around one big place image, right? And yeah, so I'm going to delete these. So these cases will just produce the images of the structures of the shape, right? And we're going to wrap them, this entire cond block, which are going to be these two images, all right, depending on the shape, into a place image. All right, so this is going to be the first argument to place image, this entire cond block. And then we have the three similar ones, half width, half height background, half width, half height background. So half width, half height background. All right, run against our test, and it's exactly the same. All right, so we know that the operations are still exactly the same. We're producing the same thing. It's just less code, right? We went from 2 place images in each branch to saying, hey, wait a second, it's only the first argument that's changing here. These 3 stay the same, so we can just wrap this into an outer place image, like so. And likewise, we can simplify this and refactor this even further if we look and see that shape arrow image does exactly this cond, right? So we can just replace this whole con with shape arrow image of the given shape, like so, right? So shape arrow image, if we give it a disk, make disk, let's say 20, right? It's going to produce that shape, like so. In shape arrow image, make box of 2010, right? Like so. It just creates those boxes. So 2040, like so. Okay, so that is pretty much the render function done. So coding up the body for that, and test reviewing and refactor for that. Okie dokie. So now let's move on to the next problem, flip-shape, all right? So this is where it gets a little more difficult. All right, so here's the signature. Flip-shape consumes a shape and produces a shape. And the purpose statement says change the given shape from a disk to a box and from a box to a disk. The dimensions should carry through the flip, all right? All right, so signature, purpose, let's just stub this out. So check, expect, flip-shape. So let's give it our disk of 30, so ds30, right? That's the make disk 30, make disk with the argument 30, all right? Just a reminder. So looking at the purpose statement, it says change the given shape from a disk to a box. So we're giving it a disk, we want to change it to a box, right? So make box, and then it says the dimensions should carry through the flip. So a box has two arguments, it takes in a width and a height. So since we have a radius of 30, we're just going to make that, radius of 30 the dimensions for the box. We're going to pass it into the width and the height, all right? Likewise, let's do the same example for flip shape of a box, of 2030. All right, so looking at the purpose statement, it says change the given shape from a disk to a box and from a box to a disk. So we're in this second part here. All right, we're giving it, flip shape, a box, and now we have to flip it into a disk carrying the same dimensions through, all right? So it's gonna be make disk. All right, and since disk only it only has a radius, right? It only has a radius, one argument, right? Unlike the two from box, which has a width and a height, right? Let's just give it the width, all right? So we're gonna say 20. Okie dokie. And I forgot to stub, so let's just stub this out really quickly. sh, and then this produces a shape, so let's just spit out the one that we're giving in as a stub to run against our tests. Like so, we get a differ. So make disk 30 differs from this. The differs are fine. They're just mismatches. The examples are valid. Going to comment out the stub here, and since this consumes the shape, we can use a template that has the scaffolding that we need, like so. And we're going to use that to leap off of for our flip shape. Okay. Just going to copy and paste this down here. All right, so now really pause the video. Hopefully this should be all the mental scaffolding needed to implement flip shape. All right, I'm gonna go with spoilers in 3, 2, and 1. All right, so I'm assuming that you took a good swing at it. So now let's go over it together. Okay, so given a disk, right, we need to produce a box, right? From this example, we need to flip this when we're given a disk to a box of the same radius, with the radius spread out across the width and height. So looking at our examples, we have to convert this disk into a box. And since box takes in a width and a height, we'll just give it the radius twice, like so. All right, so that's one example done. Move on to the next one. If we're given a box, we're just gonna take the width and then make it the radius of a disk, right? So that is how we are flipping the structures of shapes. All right, so make disk, and we can delete this height here because we don't need it, like so. I'm gonna hit run, and all our tests should pass. It does look like I had 2 extra parentheses. All right, if I run this. All right, so they all pass, like so. And we can play around with it here, right? So if I do flip shape of make disk, 100, right? This is going to flip that disk into a box with the width and height, like so, and vice versa. If I give it a box of, let's say, 99 to 100, right, it's going to make a disk of 99, all right, like so. All right, so let's move on to our next function, handle key. But before we do that, we have enough to just run this Big Bang application, right? So main consumes a shape, right? So let's just call main with a shape and it'll work, right? The handle key is commented out, so we don't have to worry about it, like so. So, and also the flip shape function isn't used yet, right? So we can just do main here, takes in a shape, right? So let's just give it one of our shapes. And it will grow that shape. But when I hit space, it's not doing anything because the handle key, I'm hitting space right now, and it's not flipping to a box because it's the handle on key handler is commented out. Likewise, if I call main and give it a box of 0, 0, 0 width, 0 height, then it's going to grow that black box, all right? Because the onTick function and the toDraw functions are done, all right? It's just the handle key that we need to do the switching, all right? So here is handle key. It consumes a shape and a key event, right? And I recommend you look at what that is in the racket documentation. But it's pretty much the strings that are the numbers on your keyboard, the numbers and letters on your keyboard. So it can be A, B, C, D, E, F, G, H, I, J, K, etc. And any key you press, we compare it with the K, E equal ha function, like so. All right. The handle key function has a special template that's not really that similar to the shape here, right? All right, it's due to the nature of Big Bang, and I don't want to get into it right now. But so, anywho, that's the signature. When the space key is pressed, change the shape from disk to box. So this arrow means disk to box and box to disk, right? Flip between them when the space key is pressed, all right? So this X should be space, right? And likewise, let's just stub this out really quickly. So this should produce a shape. So let's just do that. So like so. All right. Next, let's come up with some examples here. So check expect. All right, let's do handle key. Do a make box. We'll say 30, 30. And then they are pressing the space key. What do we expect to produce? Right. Well, looking at our purpose statement, right, this has to produce a shape, and that is the flipping of the shape when the space key is pressed. So flipping this box, we're going to make this box a disk. So we should produce a disk with the dimensions 30, right? Because we're just taking the width and slapping it to this radius of the disk, all right? So make disk 30. Likewise, if we do the reverse, right? If we're given a disk of, let's say, 100, and someone's hitting the space key, well, we want to turn this disk into a box. So we expect to produce a box with the radius spread out in the width and the height, right? The radius is 100. We're making a box with 100 like so. Let's do one more example where some irrelevant key is pressed, right? So we're given a make disk 100, and let's say someone pressed the A key, right? What do we expect to produce? Well, looking at our purpose statement here, when the space key is pressed, right? If the A key is pressed, right, then nothing should happen. We should still produce a shape, right? Looking at the signature, the same shape that we're passing into handle key. So it should still produce make disk of 100. Okie dokie. So signature, purpose, stub, right? Examples. All right. If we run it against our examples, everything's still good, right? Just get mismatches. All right. So pause the video and try to use this as a template. All right. As a template for the handle key function. All right. And huge chance, use the flip shape function. All right. Spoilers in 3, 2, and 1. All right. So I'm assuming that you took a good swing in it. So now let's go over it together. All right. So when the space key is pressed, change the shape from a disk into a box, right? Flip between them. So we have a function that flips between them when given a shape, right? Like so. So we're just going to pass it into it like so. Flip shape. All right. So this reads when the space key is pressed, right? This is that condition. Flip the shape. Otherwise, the shape remains the same because we're just spitting it back out. All right. So if I run this, it should pass all those tests, and so they do. So we can comment out our on key here, handler, and run it. And when I hit space, it should do that. So main make disk of 0. And when I hit space, it should switch between them while retaining the dimensions somewhat, right? It's due to the way the circle has a radius, all right, that makes it grow a little faster, all right, because it's a little bigger than the box, but nonetheless, like so. Okie dokie. So, gonna mark myself done for all these steps, right? Test, review, and factor. All right, hit Control I. Right, make sure everything's indented. Let's make this comment. Start the world with main, make disk 0. Right, you can copy and paste this down below and run it automatically when we hit Control R, like so. All right, I'm gonna comment it out. Okie dokie, like so. So that was a lot for this video, right? So we instantiate the template multiple times, right? And this is where it's starting to shine a little more, right? Shape-temp, we used it once here for grow shape, twice here, right? Shape arrow image, this is the second time. 3 times for render, but we decide to refactor that. 4 times for flip shape, like so. And pretty much more or less 4 times, right? So if you weren't writing the template before, well, you should get started because it's going to create a really good scaffolding when problems get much harder, right? The pieces are laid out, all laid out, and all you have to do is just manipulate and rearrange things. Okie dokie. So submit this to Handin and check your score. It's called 12.0 flip shape. So 12.0 flip shape, and yeah. All right. Make sure it passes the creator test. Anywho, that is about it for this one, and I will catch you in the next one.